प्रीवियस वीडियो में हम लोग ने डिस्कस किया था कि जब हमारे पास दो कर्व गिवन हो और वो कर्व्स से जो रीजन बाउंडेड हुआ है उसको हम रोटेट करेंगे अबाउट एक्स एक्सिस और लाइन पैरेलल टू एक्स एक्सिस, देन हाउ टू फाइंड द वॉल्यूम ऑफ दैट सॉलिड रीजन। ओके, बट इन दिस केस इस वीडियो में हम लोग ये डिस्कस करते हैं कि अगर वो रेवोल्यूशन जो है, कोई दो कर्व गिवन है और उनके से जो रीजन बाउंडेड हुआ है उसको हम रोटेट करेंगे अराउंड वाई एक्सिस और अ लाइन पैरेलल टू वाई एक्सिस, देन व्हाट शुड बी द केस, और उस प्रॉब्लम को हम कैसे हैंडल करेंगे, लेट्स सी। ओके, and I want to revise one thing, that we will use this formula. Suppose we have two curves, that is x equal to fy and x equal to gy are the two curves and c to d. तो ये जो रीजन बाउंडेड हुआ है by these two curve and these two lines की तो कोई प्रॉब्लम नहीं है, that we will see that how to calculate the limit. But the region bounded by these two curve and the revolution is taken about y axis or any line parallel to y axis. That's the case here. ओके, तो जैसा कि हमने डिस्कस किया था कि अगर y एक्सिस या फिर कोई लाइन पैरेलल टू y एक्सिस है तो उस केस में वी नीड r dy, r y dy. इट मीन्स दैट द रेडियस इन टर्म्स ऑफ y, इट शुड बी द लिमिट ऑफ y एज वेल. ओके, सो लेट अस सी वन क्वेश्चन, दैट इज find the volume of the solid of revolution of the region bounded by these two curves. When these two curves, the region bounded by these two curves is rotated about y axis, then what should be the volume? That's the question. Okay, तो y axis के about revolution है, तो एक पहले हम इसका रफ स्केच ड्रॉ करते हैं. तो that will look like y equal to x, so it's a line like this, and y equal to x square will be like this. Okay, therefore the region is region bounded by these two curve, one line and one curve, is given by this one. This is my region. Okay, and this is my region, but this region is rotated or revoluted or इसका revolution होगा that is about y axis. तो y axis से revolution होगा. It means that we need the radius, और radius is the distance between the axis of rotation and the curve. तो यहाँ पर दो axis of rotation, एक axis of rotation y axis है, and the curve is y equal to x square. So this one is, I will say here, this one is y equal to x square, and this line is y equal to x. Therefore we need to calculate the radius. तो सबसे पहले देखते हैं रेडियस क्या होगा. जैसा इसमें मैंने यहाँ पर बनाया है कि दो हमारे पास हैं, तो this one is called the outer radius and this one is called the inner radius. So we will apply the formula that pi limit of integration c to d r outer radius square minus r inner radius square and dy. And because the line because the revolution line is y axis, therefore the distance therefore we need the radius in terms of y. Okay, so radius will be like this. So this will be r outer radius, and this will be my inner radius. Okay, so r in. Okay, so how r outer will be calculated? So you need ry dy. So what is ry from this one? So directly I will apply the formula, volume equal to pi, limit of integration is c to d, and what is c here? Of course it is 0 comma 0, the point is, and this point is 1 comma 1. You can simplify very easily. Y equal to x and x square, therefore x square equal to x, so x into x minus 1 equal to 0, so that will give you 0 1. And when x is 0, y is 0, and when x is 1, y is 1. Therefore 1 comma 1 and 0 comma 0 are the 2 points. So what is my limit of integration? So I will take here that this is my limit of integrations from 0 to 1. Okay, so limit of integration is 0 to 1. Now this will be, so what is my outer radius? So this will be y equal to x square, therefore x is square root of y. So outer radius square, that is root y square, minus our inner radius will give you x equal to y, so I need y square. Okay, and the only thing is to calculate the definite integral. So it is pi and 0 to 1, and this is y minus y square dy. So it will be pi, and this is y square by 2, minus y cube by 3. So that will give you 1 over 2 minus 1 over 3, that is pi over 6. Okay, so it is the case when the revolution is taken about y-axis. Now I am taking another example that's a different from here, from this example. So find the volume of the region bounded by these two curves when it is rotated about x equal to 3. So the curve is y equal to x square plus 1 and the region bounded by y equal to x square plus 1 and y equal to 5. हमें ये देखना है. तो ये कैसा होगा? That will look, it's x axis and y axis, and y equal to x square plus 1. So let us look at how it will look like, x square plus 1. Okay, and the line is y equal to 5. So I take here somewhere, line is y equal to 5, and this one is the curve, that is y equal to x square plus 1. Okay, and when this region, so my region is this one, so my region is this one, is my region. Okay, and when this region is rotated about the line x equal to 3, so mark with different pen, x equal to 3 is somewhere here, or distance can be, but it's a rough sketch, so there is no problem. Okay, and from x equal to this region is rotated about the line x equal to 3, therefore it's a case of the line, rotation line is parallel to y-axis, therefore we need ry, radius in terms of y. So let us look at that, what is my outer radius and what is my inner radius. That's the only thing which is required. So here the outer radius is what? Outer radius means the distance, this distance between the axis of rotation and the curve. So this will give you r out. And what is the inner radius? That will give you this r in. But the definition of the radius will remain the same. That's a distance from the axis of rotation to the curve. Okay, now just we have to calculate what is r out and what is r in. Okay, so I will directly write the volume, that is pi, and limit of integration will be of course from 1 to 5, because ry dy, so dy is that, so limit जो है y की लगेगी. And what is r out? Look at this distance. This distance is what? It is 3. Origin to the line x equal to 3. So this distance is 3. And if you want this distance, then it is 3 minus this curve. But remember my point, you need ry. Therefore, y equal to x square plus 1. So x in terms of y will be square root of y minus 1. Okay, so this will be 3, and this is my additional distance. This is my additional distance. So that will be 3 plus, so r out is what? So I will write it separately, that r out is what? R out is 3 plus square root of y minus 1. And what is r in? R in will be 3 minus square root of y minus 1. Now you have the formula, that r out square, that is 3 plus square root of y minus 1 square minus r in square. So what is r in? That is 3 minus square root of y minus 1, and this is again whole square. So I will write here that it is a dy. Okay, so this is my r out and this is my r in. So square of these two by using the formula. So I will just calculate the definite integral, and the answer is, final answer will get, so that is 1 to 5, and this will be 9 plus y minus 1, close the bracket, plus 6 times square root of y minus 1, simply a plus b whole square, minus, I will apply the bracket here. So 9 plus, it is y minus 1, and this will be 6 square root of y minus 1 and dy. So this will be volume pi equal to, v equal to pi, that is 1 to 5, and this 9 cancel, y minus 1 will be cancelled. So 6 plus 6 will give you 12 y minus 1 square root dy. So it is 12 pi, v equal to 12 pi, and this will be integration of y minus 1 to the power half, that is y minus 1 to the power 3 by 2 divided by 3 by 2, and the limit of integration 1 to 5. So that will give you here 3 to the 3 4s are 12 and 4 to the 8. So I have 8 pi, and apply the upper limit, that is 5 minus 1 4, and so write it again, 4 to the power 3 by 2 minus it will be 0. So that is 8 pi, and 4 to the power 3 by 2 can be written as 2 square. So the exponents will multiply and 2 will be cancelled. So only 2 cube is left, that is 8. So the answer is, final answer is 64 pi. Okay, so in this way, in this video we have seen the case, so we have seen the case in which the rotation line is y-axis or any line which is parallel to y-axis. तो हमने दोनों वीडियो कवर किए जिसमें हमने दोनों ही केसेस डिस्कस किए, किसी लाइन के अबाउट रेवोल्यूशन हो या एक्सिस के अबाउट रेवोल्यूशन हो, तो इसकी प्रॉब्लम्स आप सॉल्व कर सकते हैं बाय यूजिंग दिस टेक्निक. रिमेंबर द टेक्निक वेयर I have discussed the radius, outer radius and inner radius. That is the best technique which I use to solve each and every problem. The only thing you need to take care about that you find the correct picture, that is a rough sketch, and calculate the outer radius and inner radius correctly. That is the only thing is the requirement. And you need to remember one more point, that is the radius is the distance from the axis of rotation to the curve. That's the only key to solve the problems of volume by washer method.